Let's return to our chart that we started in another video, and let's look at the next method for solving a quadratic equation, and that is called completing the square. The advantages are it can always be used with any equation. However, it's not always the best choice to use, and you're going to see why in a minute. The disadvantages are it requires more steps than other methods, and there's really only a couple of times when it is probably your best choice. The equation preparation is that you are going to get, let's go back to the definition of a quadratic equation. It looks like this. The preparation is you're going to isolate the x part so that it's ax squared plus bx, and then you're going to put the c on the other side so that you're going to isolate just these x parts, the x squared part and the x that's not squared part. So let's look at some examples of how you actually do completing the square. And I'm going to tell you that it's involved, so just sort of hang with it. I have the directions condensed at the top. Rather than reading them, I'd rather just walk you through one. So first off, you have to isolate just the x pieces and put the number part on the other side. So I'm going to subtract a 10 to get it ready, but when you write it, you're going to write x squared plus 8x plus some magic number, because we're going to be adding something to that, equals the negative 10 that you moved over plus the same magic number. Because you know that in order to keep an equation balanced, you have to add the same thing to both sides. Now, how do I figure out what that magic number is that I want to add? What you do is you take the middle coefficient, which is positive 8, you divide it by 2, write the sign with it. I always draw a circle around it. I'll show you why in a minute. And then you square that number. That is what we are going to add to both sides. So I'm going to add a 16 and a 16. Why are we doing that? Because we're trying to force the left-hand side of the equation to be a perfect square trinomial. And now it is a perfect square trinomial. If you go to factor this left-hand side and you say, I want factors of positive 16 that add up to positive 8, those factors are positive 4 times positive 4, which means it's x plus 4 times x plus 4, or x plus 4 squared, and that's what I wanted it to look like. So I forced it to look like that by adding a 16. Notice, plus 4, that's what I had in my circle. That's why I circle it. On the right hand side, I have a negative 10 and a positive 16 is a positive 6. And now if you'll think back to the method that we did before this one, the square root property, my equation is now in the correct form for taking the square root of both sides. So I'm going to do that. So from here on, you know how to do it. X plus 4 equals plus or minus square root of 6. I subtract a 4 from both sides, and I get x equals negative 4 plus or minus the square root of 6. So I solved this by forcing the left-hand side of my equation to become a perfect square, something times itself, and then I wrote it as that something squared and took the square root of both sides. Let's try another one. We'll go through another one. And you might already be feeling suspicious of when this is a good method and when it might not be a good method. If not, you're about to find out in just a few minutes. So let's look at a second one. I've got x squared minus 6x minus 12 equals 0. To prepare the equation, I need to get the x's isolated with the number on the other side. So I write x squared minus 6x plus some number I don't know yet equals 12 plus that same number on the other side. How do we find that number? We take the middle coefficient, we divide by 2, circle that, Now square it. That is the number that we add to both sides. And what I now have is x squared minus 6x plus 9 on the left. That is a perfect square trinomial. It's going to be x, and then what you have in the circle, minus 3 squared. Again, think about it. If you factored it, we'd look for factors of positive 9 that add up to negative 6. They're negative 3 and negative 3, or x minus 3 squared, equals 21. Now, to finish it, we're going to take the square root of both sides. So now we're back to that other method. X minus 3 equals plus or minus square root of 21. Add a 3 to both sides, and we get x equals 3 plus or minus square root of 21. It's a really, really easy method as long as two things are true. One, the coefficient on the squared term has to be a 1. So in your ax squared plus bx equals c, you want a to be 1. Secondly, and you may have figured this part out, you want the b to be an even number. And if it's not, I have to be honest with you, I would not use this method. And I'm getting ready to show you why, because we're going to do one where the middle term is not an even number. So let's prepare the equation by isolating the x parts. X squared plus 5x plus some magic number equals 1 plus the same magic number. How do I find the magic number? I take the middle term and I divide it by 2, and this is why you want it to be even, because it won't go evenly. We just circle that. That's what we're going to use. And that means I have to square that, which is 25/4, which unfortunately means that is the magic number that I am adding to both sides. Now, it's not quite as terrible as it looks, because the left-hand side is still a perfect square trinomial, and if I factored it, which you don't know how to factor that, it's still going to be this, x plus this twice, so it's still going to be x and then what you have circled, plus 5/2 that got squared. Over here, to add those, I have to change my 1 to a 4/4. I'm going to do that right here like that, kind of cheating a little bit, so that I have a common denominator, and I end up with 29/4 on this side. Still, it's not pretty. Take the square root of both sides, and I end up with x plus 5/2 is equal to plus or minus square root of 29 over square root of 4. Now, the reason I separated that square root is because I can actually take the square root of 4. It's 2. So I have x plus 5/2 equals plus or minus square root of 29 over 2. Let's bring this up here to work so you can see. I need to subtract a 5/2 from both sides. It's going to be x equals negative 5/2 plus or minus square root of 29 over 2. So I hope that convinced you that completing the square, although a very simple method, really is only a good choice if your a is equal to 1, that's the coefficient of the x squared term, and the b is even. Otherwise, you probably don't want to do that. Let's kind of review two of the methods that we've done so far, the square root property method and the completing the square. And you're going to see why, because this is going to bring up our imaginary numbers again. So let's look at example 3a. I have something x squared equals negative 15. So what's been squared is isolated, so I can take the square root of both sides. The square root of x squared is x. I have a plus or minus, but I have to pull out the I. 15 radical and then I. So it's x equals plus or minus square root of 15, and the I comes on the outside. So you can have complex numbers come up or imaginary numbers come up in the solution set to these. Here's another one. What got squared is already isolated, so we're going to take the square root of both sides. That minus sign is in the square root. I kind of drew on it. Square root of x plus 2 squared is x plus 2. Square root of negative 16 is plus or minus 4i. Now I'm going to say that I'm going to subtract a 2 from both sides, and I get x equals negative 2 plus or minus 4i. And you cannot combine those two terms. They're not like. All right, let's look at our last one. On this one, we're going to complete the square. So subtract a 7 from both sides. I have a 1 here and an even number here, so this is a good choice. And it's not factorable. X squared plus 2x plus some magic number equals negative 7 plus the same magic number. I find the magic number by taking my middle term, divide it by 2, circle it, square it, add it to both sides. This now has been forced to become one of these, and I knew what it was because of what's in the circle, equals negative 6. Take the square root of both sides, x plus 1 equals plus or minus square root of negative 6. Let's do some cleaning up. First, let's pull out the I, so that's gone. Subtract a 1. X equals, now you got to figure out how to write this. It's negative 1, that's the real number part, plus or minus square root of 6, and then the I is kind of off to the side like that.